Welcome to One Chemistry. Always try to do your best. Now, let us see about 100 conversion in organic chemistry. We are seeing it as episodes. This is the episode number 92. If you didn't watch previous episodes, I encourage you to go and see. Here, we solve 5 problems step by step. Stay tuned. Let us see the question number 1. Starting metal is cyclohexanone attached with methyl group. Then you are adding alkene which contain 2 bromine, which is in the second position as well as third position dibromine. Then next step you are adding LDA and THF. They ask you to find the product. The products are coupled reaction, new CC bond is formed. But where the CC bond is formed is the real question. In which alpha position, or the double bond is attaching, or bromine is attaching, or which bromine attacks. So really the question is about regioselectivity and which bromine reacts there. The answer is B. Let us see how. The starting metal you have ketone and you have 2 alpha hydrogen. There are the 2 possibilities of proton abstraction. But always the stable product is formed. The 2 possibilities are discussed here. One is tertiary anion and secondary anion. Among the anion, primary is more stable, then secondary, then tertiary. So the secondary anion is more stable, it is the major product. Next step you are adding dibromo compound with alkene where it will be reacting. Normally the reaction center will be the very good leaving group. Here bromine is the leaving group. Again the question, which bromine will leave here? Bromine with sp3 carbon leaves because electronegativity of sp2 carbon is higher than sp3 carbon. So the bromine with the double bond cannot leave easily, but single bond can leave easily. So the bromine in the 5th position reacts. So bromine in the 5th position leaves, direct CC bond is formed here. The whole question is about selectivity, where the product forms, where the anion forms, where is the reaction center. So you have to be a master of fundamentals. Here you have to learn 2 important things. Whenever the intermediate formation, you have to have the stable product formation. Here 2 anion formation, among that the secondary is more stable than tertiary. The second selectivity comes from the leaving group. The leaving group attached with the less electronegative carbon leaves here. So the bromine attached with the sp3 carbon leaves here. Then the question number 2, the starting metal you have ketone attached with tertiary butyl group. Another side you have cyclopentanone which attached with rigid ring. The reagents are same, LDA and benzaldehyde. They ask you to find the product there. The products are mostly the direct coupling of benzaldehyde and starting material, but the configuration of both groups are important. The condensed product, whether the condensed carbon is syn to each other or trans to each other, even with the ring syn to each other or trans to each other. The whole question is about formation of condensed product and its stereochemistry. So from the reactant to product you might understand that the reactivity versus stereochemistry is important here. The answer is C. Let us see how. Here we have both starting metal which contain carbonyl group. You have one side tertiary butyl, another side cyclopentyl. Here you are using LDA. LDA forms enolate. Here the important things comes. How the enolate form here? Here tertiary butyl group is there which is very rigid. So the starting configuration retained there which is in the Z form, or you can say cis form. So it condenses with aldehyde form new CC bond. It also in the syn form. So you are starting from Z and end with syn. So alkene is in the cis form in end with syn form. So it's a straightforward and simple. Second reaction you just see that you have ketone and you are using LDA. Same enolate is formed, but enolate here is E because you have oxygen there. The configuration the E configuration, or you can say trans configuration. So once condensed, product also become anti there. So the product converts E form into anti form. So the same configuration maintained throughout that one. So the answer is clearly C. P is in the syn form, Q is in the trans form, or you can say E form. Here you have to learn 2 important things. Whenever you have restriction, here tertiary butyl group is the restricted group, as well as ring is prevent the restriction there. So the configuration of the starting metal maintained there throughout the reaction. because inlet is just a double bond formation, so configuration retained there, it directly converted into product. If it is a Z alkene, it converted into syn form. If it is a E alkene, it converted into anti form. Then the question number 3, the starting metal is 6-member ring which have alkene inside and you have acid in the side chain. You are using iodine and sodium bicarbonate. They ask you to find the product. Here products are mostly cyclized one. So how the cyclization occur, whether in the syn form or in the trans form or the 4-member ring and 5-member ring. It's just a ring closure but in the selective way. So from the reactant to product, ring size is important as well as the configuration is important. So the question is really about regioselective ring closure. The answer is D. Let us see how. The starting metal you have alkene and acid, you are using sodium bicarbonate. The sodium bicarbonate abstract the proton from there. So base abstract the proton there, you have anion formation. So the anion is there, you have alkene inside. Next step you are using the iodine. So what really happened is the double bond ionated by the iodine there. So iodine is attached with the ring. Here second iodine attack is not possible because of bulky iodine. Iodine is very bulky, it cannot allow the second one there. So O minus is the nucleophile there. So O minus attack the ring. Here to identify the stereochemistry you have to write as cyclohexene form. So cyclohexene contains the double bond. You have to draw like twisted chair form. So the attack is from the below, iodine is above. So the final product also reflects the same. So ring closure is occur, iodine will go above, the oxygen will be below. The answer is clearly D. Here you have to learn two important things. Dehydrogenation is definitely possible because iodine is bulky, the second iodine will not attack there. Second thing is you have to know whenever cyclohexene comes, you have to imagine the twisted chair form. Then the question number 4, the starting metal is cyclopropane which are attached with trans methyl group. You are using bromine in dark condition. They ask you to find the product. The products are mostly dibrominated product. How the ring is open here? The ring open between methyl group or ring open between two methyl and hydrogen or the ring opening with rearrangement. So from the question to product you might guess the regioselective ring opening definitely occur. You have to guess the product whether there is a rearrangement occur or not. The answer is D. Let us see how. The starting metal you have cyclopropane which is a very strained system. Then you are having dimethyl group. Dimethyl group create very strong steric crowding. So what really happens is ring is opening on B. So ring open there, you can guess positive and negative anion. It is for your understanding. Actually the mechanism is just opening one without any charges. So we redraw to the straight line, then you are attacking with bromine. So the straight chain anion and cation forms. Your next step you are using the bromine there. So what really happened is bromine attached there because bromine form bromine plus and bromine minus. So the product is clearly D there. Here you have to learn two important things. Stereochemistry plays the role here. Here steric effect dictates the reaction. You have to guess where is the steric crowded center and you have to find the product there. Second thing is about stereochemistry there. Here stereochemistry doesn't have any importance here. Both are in antiposition, doesn't have any effect. Then the question number 5. The starting metal is bicyclic system. Inside it has alkene there. You have alcohol and you have vinyl group. You are using KH and THF. KH is a strong base. You are using the heat. They ask you to find the product. The bicyclic system ring is broken. So all products are fused ring system with two 6-member ring. And how the ring is fused is the real question. Rings are fused in the syn fashion or in the anti fashion. The carbonyl group in the 5th position or the 6th position is important here. So the stereochemistry and position of carbonyl is important here. The question is really about bicyclic to fused ring system, how it converts the double bond and carbonyl position. The answer is D. Let us see how. The starting metal you have alcohol and you are in the strong base. Base abstract the proton there, you have anion formation. Here you have two double bonds, so you might think of sigmatropic rearrangement. Here 3,3 sigmatropic rearrangement because 6 carbon terminal double bonds are there. So the sigmatropic rearrangement. So the bonds are switches, third bonds promote the reaction, 3,3 bond will be there and 2 form alkene and 1,1 breaks, 2,1 form alkene there. So you have alcohol near the alkene, so it converts into ketone. So hetoenol tautomerism is occur there. If you redraw nicely, you have answer D. So you have starting metal converted into fused system by 3,3 sigmatropic rearrangement. Here important thing you should know is the rearrangement is the concerted mechanism, all occur at the same plane, hence both hydrogen is above the plane here. Here the whole structure is destroyed by 3,3 sigmatropic rearrangement. You convert bicyclic system into fused system. Here you have to learn two important things. One is if you have dialkenes, you have to think of 3,3 sigmatropic rearrangement. Second thing is the sigmatropic rearrangement is a concerted mechanism. So you have to imagine the all thing happen in the syn position, or you can say cis fashion. So both hydrogens are above the plane here. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.